Hello students, today we will be learning about the fundamental theorem of calculus part 1 and part 2. So first we need to ask ourselves, what is the fundamental theorem of calculus? Well, the fundamental theorem of calculus is the formula that relates the derivative to the integral and provides us with a method for evaluating definite integrals. So this right here at the bottom is the formula for the fundamental theorem of calculus. Once again, up top you have the formula for the fundamental theorem of calculus. Part 1 of the FTC tells us that we can figure out the exact value of an indefinite integral, which can be used to find the area under the curve when we know the interval over which to evaluate. In this case, it will be the interval a and b. So here are some basic step-by-step rules on how you can apply the fundamental theorem of calculus. You can go ahead and pause the video here to take an in-depth look at these basic rules. So let's go ahead and do some examples, y'all.
Okay, students, or whatever, we're going to break down this problem. You see right here, we're going from a to x for f of t dt. So the first thing to do the FTC part 1, we're just going to split this up because by the theorem there says that there must be some point between a and x. So we're just going to find that point. In this case, we're going to use 0. So let's do that. So the integral from a to 0, f of t dt, plus the integral of 0 to x, f t dt. And that's the first part. Okay, so let's actually do an actual problem, the one right here. You could pause the video anytime, just copy it down and follow along. So for the first thing we're going to do is like how we did for the other part. We're going to split this up because, like I said before, in between tangent x and x squared, there has to be some point, and usually that point is 0. And let's start that first. So it's going to start at tangent x to 0, and then you add the equation. 2 plus t to the 4th dt plus 0 to x squared, and then you add the equation again. 2 plus t to the 4th dt, and then from there, since usually this format is not really ideal, we usually end up flipping it. So in order to do that, we have to change this to a negative and switch these. Tangent x to 0. And from there, that's the first part. And from there, we just usually end up plugging in the tangent to the variables. In this case, we're going to plug in the x squared to the t to the 4th. And so we're going to do that. We're going to plug those in. 1 over 2 d2 plus tangent x to the 4th times dt, so that's the derivative of t. In this case, the t would be the tangent x, so the derivative of tangent x would be secant squared x. I'm just going to remind that that's going to plug in for t. It's be secant squared x because that's the derivative of tangent of x. And you add the derivative of x squared, so in this case it would be 2x, and then you just plug it in for the bottom too. X squared to the 4th, and then to reduce that, that'd just be x to the 8th. And that's it.
So now that you have done some examples for FTC part 1, we are going to talk about FTC part 2. So let's go ahead and do some examples. Hello students, today we will be talking about the fundamental theorem of calculus part 2.
Yeah, we will.
So this is the formula for the fundamental theorem of calculus part 2. Today we will be doing this example where we will be applying this formula onto this example. So let's get started. So first we need to integrate, which this will be converted into x cubed over 3. And this will be converted into 3x.
Ooh.
So here are our values. This is our a value and this is our b value. So now we need to apply this formula. So we will begin by plugging in our b value, which is 7.
Ooh.
So this will be 7 cubed over 3 plus 3 times 7 minus, go ahead and bracket that off just so that you won't get confused. This is going to be 1 cubed over 3 plus 3 times 1. Again, bracket that off just so you will not get confused. So as you see here, this is f of b. Like I said, this is our b value and this is our a value.
Damn right.
So f of b minus f of a. Now from here you can simplify if you want, but it is not necessary.
What do you have for Q's?